So this is our Day 1 notes. We are talking about properties of polygons. It's section 11, topics 1 and 2. Two things that we've talked about before. The first is regular polygons. That word regular, that means that they have the same side and angle. So this over here would be an example of a regular polygon. It's regular because all the sides are the same and all those angles on the inside are also the same. Irregular polygons do not have congruent sides and angles, so they are irregular. They're different. They look weird. An irregular polygon might look like that. So on this polygon here, it has 1, 2, 3, 4, 5, 6, 7 sides. We're going to find and mark the center of the heptagon. Heptagon means 7 sides. So the center of this heptagon is maybe right about here. The circumcenter is the point that is equidistant from each vertex. So that means each vertex is each corner. And this point here is the same distance from every single corner. Draw a circle outside the heptagon that only touches the vertices. So outside, we're going to draw a circle. And we're going to try and get it so that it only barely touches each corner. The outside circle is called the circumcircle. Part 3. Draw a circle inside that touches each side of the heptagon at its midpoint. So this circle, I'm going to use a different color. And it is drawn inside the circle this time, and only touches each side. The inside circle is called an incircle. Just like it sounds. Inside circle. It connects all the midpoints of the sides of the polygon. So that's a midpoint, that's a midpoint. From A to B, that's in the middle. From B to C, that's in the middle. C to D, right there. All those points where the circle's touching is the middle of each side. Draw a line from the center of the heptagon to one of its vertices. So I'm going to go from the center to E to D. This is called the radius. So all of these are radii of the polygon. Draw all of them. So I'm going to continue from the center to C, from the center to B, to A, to G, and to F. We have 7 isosceles triangles. What's special about an isosceles triangle is they have 2 equal sides. Just a little refresher, jot that in. So the isosceles triangles, these sides are equal. All the radii of this polygon are going to be equal to each other since it's regular. So within each isosceles triangle, these are the congruent sides. The height of each triangle is called the apothem. The apothem is going to be really important when we get to area. So I'm going to write involved with area, and I'm going to draw one of the apophthegms as this dashed line and label it with a little A. Okay, so this next part, it says hexagons. We're going to draw all the radii on the hexagon, talk about what kind of triangles formed, and then draw the apophthegm on it. So I'm going to pause this, give you a moment to draw all the radii on it. Okay, so my lines got a little out of whack there, but they're supposed to be completely straight. When I draw this, if it's a hexagon, I know that these are going to be equal, but with hexagons, all three of those sides are equal. So we form an equilateral triangle, and I'll talk about how I know that. I know that it's equilateral because I have 6 little sections here that all make up this 360 degrees. If I take the 360 and then I divide it into 6, I get a 60-degree angle here. These two angles also are 60 and 60, so I make up 180 for my total degrees there. If I have 60 degrees for my angles in my triangle, all 3 angles are the same, so all 3 sides are going to be the same. Therefore, it's equilateral. Make a little note to yourself that this is only with hexagons. With any other polygon, it just makes isosceles triangles like we talked about before. Next part, draw the apophthegm of one triangle. Okay, I'm going to pause this, let you draw the apophthegm of a triangle. Here's mine. Straight down, forms a 90-degree angle there at the bottom, and I'm going to label it with an A. If the radii is 4, find the length of the apophthegm. Okay, so this is where we have to label the triangle, and we're going to use either our trig or special right triangles that we learned in section 8. I already know that these base angles are 60. And I know that this top angle was 60, but I divided it in half when I did my apophthegm, so that's going to be a 30-degree angle now. I now have a 30, 60, 90 triangle. So I'm going to redraw that over here. That's my A. This is the radius, which was 4. I'm going to label that 4. And this is a 60-degree angle and a 30-degree angle. Now if I remember my special right triangles, across from the 90-degree angle is always going to be twice as long as it is across from the 30 degrees. So my small side's 2. Zoom in a little bit. And my side across from the 60-degree angle is 2 times the square root of 3. So, quick refresher on 30, 60, 90 triangles. We have across from each angle, we have a short side. Let's say the short side is just 1. Then we have a medium side, which is the short side, times the square root of 3. And then across from the 90-degree angle is the short side times 2, so 2. So here we had 2 as our short side. So we have 2 square roots of 3 as our middle side and 4 as our long side. This next section talks about breaking up irregular polygons. So all along we've been talking about regular ones. Here we are going to break up this irregular polygon into rectangles and triangles to find the perimeter and area. So I've already broken it up into a rectangle in the middle and 2 triangles on either side. So we have to find the area of all three of these, add it together, and that's going to be the area of the whole shape. As a refresher, the area of a rectangle is equal to base times height. The area of a triangle is 1/2 times the base times the height, or base times height divided by 2. So I'm going to give you a minute to find the area of this rectangle and the area of our two triangles. Okay, so the first thing that I did was I labeled the base of my rectangle 8 and the height 6. All I did was I got that from the opposite side. Next, I found the area of my first triangle, 1/2 base times height, so 4 times 6, then you got 12. Then, the area of my rectangle, just base times height, so 8 times 6. And finally, the area of this triangle over here on the right. The base, if you can flip it in your mind, the base is 6, and the height is however tall it is from the base to the vertex on the opposite side. We can use the fact that we know this whole thing is 15. And subtract off the 8 and the 4 to see what's left. So 15 minus 8 minus 4 gave me 3. So I knew that the height of this triangle was 3. So I do 1/2, 6 times 3, and I got 9. After that, the total area is equal to 12 plus 48 plus 9, and you get 69. So next is the perimeter. That's just around the outside. So for the perimeter, I just need to add up all the way around the outside. And I have pretty much every length I need except for this one right here, which we'll call x. This is the hypotenuse of a right triangle, though, so I can use the Pythagorean theorem, a squared plus b squared equals c squared, to solve for x. So I have 4 and 6 as my two sides, and I'm looking for the hypotenuse. Get 16 plus 36. Add those together. And I need to take the square root. You get 7.2 is equal to x. So I'm going to jot that down here. Oops. Now, I just add up all these sides. So 7.2 plus 4 plus 8 plus 5 plus 5 plus 8. Let's see what we get. 37.2 for my perimeter. Okay, go ahead and turn to the next page. We have 4 shapes here. We have a pentagon, a octagon, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, a hexagon, and a shape with a lot of sides there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And I want you to mark the central angle in each polygon and calculate the measure for each and the base angle that for the triangle that's created. So we're going to go through the first one together, and then I'm going to have you guys do the other 3. So the central angle is right there in the middle. We're going to create that by drawing 2 straight lines to either vertex. I'm going to continue that. So to find the central angle, that's what they're asking for right there. We are going to take 360, because that full circle, if I put all 5 of them together, would be 360, and divide by 5. That gives me 72 degrees. So that angle, along with every single other one right here in the middle, is 72. Part B asks for the base angle for the isosceles triangle that's created. So because it's isosceles, those are the same, and these 2 angles are the same. I know that a triangle has 180 degrees. Subtract the angle that you're given, and you're left with 108 degrees. And then I'm going to divide that between my 2 angles to get 54. So this one is 54, and that one is also 54. So go ahead and do these other 3 with your table, the exact same thing. Find the central angle here, and then find each of the base angles in the isosceles triangle. So if you wanted to know any of these, they're going to be exactly the same. All 72 in the center, all 54 for the base. You don't have to mark every single one like I am here. You can just do one of the triangles in each of the shapes. So here's what I got for the other 3. We have a 45-degree angle, 67.5, and 67.5. We have a 60, 60, and 60. That's our hexagon, so it makes an equilateral triangle. And I want you to jot that down. Hexagon creates equilateral, which means it's equiangular as well, so all 3 angles are 60. And then this final shape was 30, 75, and 75. So moving on, this next part is going to be a little bit of review from our sections 4 and 5. The first part is the sum of the interior angles of a polygon. The sum of the interior angles, so that's meaning all of these angles right here on the inside around the entire shape, adding all of those together, is 180 times n minus 2. The sum of the exterior angles is always equal to 360 degrees. So the exterior angles, if you remember, are all around the outside. Around the outside of the whole figure. So we're going to go over a couple of these practice problems together, and then you're going to do the rest on your own. So the first one says, the sum of the interior angles is 1,620 degrees. How many sides does the polygon have? So I have my formula up here. It's S equals 180 times n minus 2. It asks how many sides the polygon has, so I need to know what n is. It tells me the sum of the interior angles is 1,260, so that's S. So I'm just going to plug in 1,260 for S. It equals 180. Don't know n, minus 2. There are a couple ways algebraically you could solve this. You can distribute the 180, or what I like to do is go ahead and just divide both sides by 180. When you do that, you get 9 on the left. These cancel to 1, and you're left with n minus 2 on the right. So I'm going to rewrite that up here. 9 equals n minus 2. I'm going to add 2 to both sides to get n by itself, and 11 is equal to n. Okay, number 2. One exterior angle in a polygon is equal to 30 degrees. So I know my exterior is always equal to 360. That's the sum. So that tells me that however many I have, so let's say if you have n exterior angles, times how many degrees each angle is, that's going to equal 360 degrees. So I divide both sides by 30 to get n by itself, and n ends up being 12. So that polygon has 12 sides. And then last one, I'm not going to go over this one in its entirety. I'm going to start you guys on it, and then y'all are going to finish it. So it says the sum of the interior angles is 5 times larger than the sum of the exterior angles. The sum of the exterior angles always equals 360. So we need to multiply 5 and 360, because the sum of the interior is 5 times larger than 360 to get 1800. Now that is my S, and S equals 180 times n minus 2. And I'm looking for n once again.